I was really surprised to learn that cancer was, associated with diabetes and insulin resistance and obesity and cardiovascular disease. The connection between cancer and metabolic disease really surprised me and piqued my curiosity. Cancer cells take up a lot more glucose than other cells and burn it without oxygen. They ferment it just like microorganisms do. Scientists understood that if a cell is going to grow, they need to take up nutrients to support that growth, but it was thought of as sort of a passive response to what was going on with the more sophisticated genetic stuff. If cancer is about these metabolic shifts inside of a cell, what is it about the way we eat that affects the way a cell eats? And that's why, the last part of my book, I really focus on that discussion.
Sam Apple, welcome to the Keto Camp podcast.
Thank you. Thanks for having me.
It is my pleasure. I'm excited to chat with you on cancer and your new book, which is all about Otto Warburg, the Nazis, and the search for the cancer diet connection. Great title. And the history of Warburg is just so fascinating. So my question to you is this: what made you want to research this topic, and why did you decide to write this book?
Sure. I was interested in metabolic disease and metabolic health more generally. I had been influenced by Gary Taubes in particular, as I know a lot of people in the keto world have been.
Yeah.
And I was really surprised to learn that cancer was, associated with diabetes and insulin resistance and obesity and cardiovascular disease. Like all the other diseases somehow felt a little more intuitive to me, but I had thought that cancer was an entirely separate story. You get an unlucky mutation or you get radiation somehow. And so the connection between cancer and metabolic disease really surprised me and piqued my curiosity. And I knew that I wanted to dig further, but, I'm a writer by training, sort of a storyteller. I did a degree in creative nonfiction. So I always look for a character and a way to tell a story. And when I learned about Warburg's famous discovery, which we'll perhaps talk about more, I became intrigued by Warburg as not only a scientist, but as a character, and learned about his story of survival in World War II. And then I wanted to see if I could put it all together and, write about a scientist's life and explain all this metabolic science in relation to cancer.
So Warburg, let's talk about him, because your book does give a really fascinating look at the history of Warburg. For some people who are listening, they probably don't even know who Otto Warburg is or the Warburg Effect. So let's go back to, what was it, 1930s, 1920s, 30s, 40s, when there was Nazi Germany and there was a lot of craziness in the world. And what happened, what transpired during those times?
Yeah, so in 1923, Warburg makes this famous discovery called the Warburg Effect now, which shows that cancer cells take up a lot more glucose than other cells and burn it without oxygen. They ferment it just like microorganisms do. And so it's a really important discovery. And Warburg also has made other discoveries about how cells breathe and use oxygen. So he's a very important scientist. And then he wins the Nobel Prize in 1931. And then in the 1933, the Nazis come along. And because he has a Jewish father, he's in a lot of danger. He's also more or less openly gay. He lives with another man. And so he's in great danger, but the Nazis ultimately protected him because they were so interested in his cancer science. And Hitler in particular was really obsessed with cancer and paranoid about cancer. So he, survives the war really because he's made this discovery about cancer and metabolism.
That's really fascinating that his research was such a breakthrough, and Hitler was concerned about cancer that he ended up sparing him. I remember you sharing about the Germany going to all these clinics and having them shut down or having them do different things, but Warburg kind of didn't follow suit. So what were some of the things that Warburg did that didn't go along with what was happening in Nazi Germany?
Oh, yeah. So, he was a part of, really incredible scientific establishment. He worked in the Kaiser Wilhelm Institute, and there were a number of these institutes that were really leading the world in science. And German science was so dominant at the time that you really had to know German and be able to at least read German to participate in many scientific fields. And so in 1933, a lot of the other German scientists of Jewish heritage flee, seeing what's coming with Hitler. But Warburg refused to budge, and the Nazis, stormtroopers come to his institute and bang on the doors and try to harass him, and he literally chases them out and screams, how dare you interfere with my research? And it's really an incredible show of arrogance, given the fact that his life could have been in jeopardy. And that's one of the most fascinating things about Warburg for me, is that he was a brilliant man, but he was also one of the most arrogant human beings who has ever lived. The famous example of this is when he was told that he won the Nobel Prize. His first response was, "It's about time." And he actually did have a pretty good case, because he had deserved it a number of years earlier. One scientist said on a scale of 1 to 10 of arrogance, Warburg was a 20. He just couldn't accept that the Nazis, were going to tell him what to do. And he called them like low life thugs, and he wouldn't give the Hitler salute, and he wouldn't put up the Nazi flag. And at the beginning, he got away with it because he was a famous scientist and he had just made this hugely important discovery. But he did, as the things got worse, he really did get into trouble, and it nearly cost him his life. It really all came to a head in 1941. They called him into a Nazi headquarters, and at that point, his international reputation didn't really matter anymore. There was no reason to protect him, and the Nazis sort of did a review of all his work, and eventually decided to spare him on the promise that he would only focus on cancer from that point forward. And it's amazing and crazy in a way that Warburg didn't leave Germany when he himself had the chance, but he thought for many years that the Nazis would fade away. A lot of people thought that. And, as I mentioned, he was so arrogant. He said that, another scientist can find a lab, but it's difficult for a king to find a new kingdom. So,
yeah, well, that's interesting. I could think of another brilliant man who's very arrogant, who's actually just the president of the United States. So speaking of which, so what happened though? Because then later on, you have this war against cancer that's taking place. And it completely, it looks at cancer as a genetic disease where, you're just unlucky, it mutates, kind of like what you shared earlier. So what happened in Warburg's research to what transpired and what is still happening with research on cancer?
Sure. So one of the strangest parts of Warburg's story, he has this miraculous story of survival in Germany throughout the war. He's the only scientist of Jewish heritage from the Kaiser Wilhelm Institutes that survives from beginning to end in Berlin at his laboratory. And then after the war, his research really starts to disappear. And, it happens. There are a number of different reasons that contribute to it. Part of it is that, new science comes along, which challenge some of his findings. But, the single biggest reason was, starting in the 1950s, they, famously discovered the structure of DNA, and that leads by the 1970s to a new sort of genetic understanding of cancer, where they're identifying specific mutations, which seem to be, the direct cause of a cancer. So the stuff that Warburg had studied, how cells take up glucose or take up nutrients and shift their metabolism, that was considered irrelevant to the more sophisticated genetics, what they call the new molecular biology. They literally referred to the the enzymes Warburg studied, as housekeeping enzymes. So, scientists understood that if a cell is going to grow, they need to take up nutrients to support that growth. But it was thought of as sort of a passive response to what was going on with the more sophisticated genetic stuff. And Warburg just completely disappeared, by the 1990s. I found an article talking about, students had never heard of them. And then in 2000, a famous paper comes out called The Hallmarks of Cancer, which doesn't mention Warburg. Famous textbook comes out in 2006, doesn't mention him. The Emperor of All Malady is a great book, but doesn't mention Warburg. It's just all the metabolism stuff is just gone. And it's amazing to me that happened. But in the late 1990s, researchers, Chi Van Dang at Johns Hopkins was one of them, Craig Thompson, now at Memorial Sloan Kettering. They started to find that these oncogenes that they had been studying, all this new molecular biology, the key oncogenes were actually controlling metabolism. They were controlling, how much glucose a cell took up or how it turned that glucose to fermentation. So it was this synthesis of, bringing all of Warburg's science into the modern era. But, for me personally, like that's a really interesting story in itself, I think. But I was interested in a secondary question, which not all the cancer scientists are interested in, which is that, if cancer is about these metabolic shifts inside of a cell, what is it about the way we eat that affects the way a cell eats? And that's why, the last part of my book, I really focus on that discussion.
That is the exact question that we should be asking. So it sounds like the fact that Warburg's research has disappeared from these recent textbooks, it sounds like it was intentional. Do you think that it was intentional, the way that it's been kind of mysteriously gone, or just by chance, coincidence?
Yeah, well, it's really interesting. And in some ways, there's another factor which I didn't mention, which is that, some scientists were suspicious of Warburg because he survived the Nazis, wondering, did he collaborate in some ways? And that also, affected his reputation. And there actually is, one very prominent scientist, Robert Weinberg, who made important discoveries of oncogenes, who, was one of the seminal people in the field and still is. And he openly acknowledged that his bias against Warburg was real. And he suspected Warburg of, being a little too close with the Nazis or whatnot. So, I think that did affect that, Weinberg wrote this or co-wrote this famous paper, the Hallmarks of Cancer, and wrote the textbook that I referred to. So I think that did play a role. And beyond that, I think the idea that, if you follow Warburg's discovery to its logical conclusion, it takes you back to diet. And there is, this huge bias against, taking diet seriously in the context of many diseases and cancer. So in that sense, I think it was intentional as well. But, I don't think there was like a conspiracy or any means to keep this out. It seemed unimportant and unscientific to a lot of people.
Yeah, makes sense. So we know that the current stats in America are 1 out of 3 women are diagnosed with cancer within their lifetime, and for men it's about 1 in 2.
Mm-hmm.
You mentioned that the question that you asked is if we could change kind of these metabolic pathways and how the body responds and turns, dims genes and dims genes down, or dims the light switch on, if you will, by what we eat. Then let's talk about what we eat. I mean, the standard American diet is 300 to 400 grams of carbs per day, typically processed foods, industrial seed oils. So let's speak about what sugar does to promote cancer growth, cancer proliferation in the body.
Sure. So the way I like to kind of focus the story is, by pointing out something really interesting that happened, which is that the first sort of rediscovery of Warburg's science took place in the late 1990s, and almost at the exact same time, a different group of scientists, epidemiologists, scientists that are just looking at cancer trends in populations, started to find like really concrete evidence that cancer was closely linked to obesity. The numbers are pretty astonishing. Now there are 13 of the most deadly cancers have been solidly linked to obesity. And I think there's a number of others that will soon be added to that list. That list didn't even include prostate cancer, and it still accounted for over 600,000 cancer diagnoses a year. So we have these two things happening at the same time: obesity linked to cancer, and a rediscovery of the cancer cell taking up glucose and fermenting it. And, I became interested in particulars, is it the obesity causing the cancer, or is there something that's perhaps driving both of those things? And, the most compelling evidence, I think, is that, it's actually insulin, elevated levels of the hormone insulin that could be responsible both for the obesity and for, giving, microscopic cancers a chance to grow and thrive. And so to me, as I learned more and more about the obesity cancer and the insulin cancer connection, then the next logical question is, okay, if it's about insulin and a related hormone, insulin-like growth factor, which, insulin can also increase insulin-like growth factor levels, then the question is, what is it about our diet that causes insulin to rise? And that took me back to sugar in particular. I mean, refined carbs in general, but sugar, I think, first and foremost. And, if you look back to the 19th century to today, the increase in sugar consumption, maps pretty closely to the rise of, diabetes and heart disease, but also cancer, begins in the late 19th century and then just goes up and up and up. And, I think that it's really about, sugar. When I say sugar, I mean, first and foremost, not just any kind of carbs, but specifically sucrose, the sweet white stuff, which is half glucose and half fructose, and seems to be better than almost any other food at driving insulin resistance and elevated insulin. And, I think that was, doesn't explain everything, but explains a large part of why cancer became so much more common in the modern world and continues to be common. And, one of the most surprising parts of my research was looking at all these populations that didn't actually have cancer, in the late 19th century and even into the early 20th century. In some cases, almost unheard of. I mean, there's maybe a rare one here or there, but as soon as they start switching to the Western diet, then, they start getting cancer and the other diseases just like everybody else. So I think it's pretty clear that it's something in the diet. And I think the strongest evidence certainly points to sugar by way of insulin.
Yeah, and you're so right. We do have a problem with spiking insulin throughout the whole day. It's estimated that 88% of Americans are metabolically inflexible. And even when you're just eating so frequently, 2 to 3 meals a day, snacking meal, you're going to have this insulin response. And I know that they've put these cancer cells into cell culture and they added insulin and it grew, right? Could you talk a little bit more about that?
Yeah, I mean, for many types of cancer, it's literally like one of the ingredients. Like if you want to grow cells in a dish, the standard protocol is to add insulin. And if you wean them off the insulin, the cells die. So it's not every type of cancer, but a lot of cancer. So, in a way, it was staring us all in the face, the whole time that this was part of the story. And again, speaking of staring in the face, even as Warburg's science about how cancer cells are taking up glucose had disappeared, at the same time, this new test came on, this new diagnostic test known as a PET scan, came onto the scene. And it really just works by showing where in the body more glucose is being taken up. And that's how you diagnose the cancer. So it was very literally staring everybody in the face. But, nevertheless, nobody was paying attention to the actual science that Warburg had uncovered.
Out of the practitioners, doctors and scientists that are doing the work right now in oncology, would you say that maybe Dr. Thomas Seyfried is kind of carrying Otto Warburg's work the most effective, or is there anybody else? Like, what do you think of Dr. Thomas Seyfried's work on this subject?
Yeah, I mean, I have a lot of respect for Seyfried because he saw something clearly that other people were missing about metabolism. And he's one of the people that put it back on the map. And, I'm sure that, I don't even know if I would have, come across this topic if he hadn't, years before me started bringing Warburg back onto the scene. So I think he gets a lot of credit, but I didn't end up, he actually thinks Warburg was largely right about everything in terms of how cancer begins, where I ended up, and he may be right, but I ended up taking a somewhat different view. This gets into the weeds a little bit, but Seyfried, points to all cancer sort of beginning in the mitochondria with problems with how a cell uses oxygen. And that's very much in keeping with Warburg's hypothesis. I think that that's certainly true in some cancers, but not necessarily true in all cancers. So I think he and I, and he's, of course, a scientist and expert. I'm just a journalist. But, I think where the overlap is in the context of, both of us seeing cancer as a metabolic disease, or, many types of cancer as a metabolic disease. Though the precise mechanisms, I was more focused on how insulin acting like a growth factor is promoting growth. And he was more focused on the mechanism inside the mitochondria. But the reason I'm mostly focused on insulin is because, I'm mostly interested in the connection between diet and cancer. And that to me seems to be the path. What he's talking about is a little downstream from the dietary stuff I'm focused on.
Yeah, got it. So when we talk about diet and cancer and insulin in this conversation, and you mentioned Gary Taubes, who has been on the podcast before. We talked about his book, The Case for Keto. We love keto here, clean keto. It's a great way to lower those insulin levels. So I know that it's not necessarily a way to reverse cancer, but as a preventative approach, what do you think about the ketogenic diet?
Yeah, I'm a huge believer in keto as a logical way to try to prevent cancer. There are no guarantees. Some cancers are just unlucky mutations, and some are inherited. But I think that most are not, and I think probably the single most important thing you can do to improve your odds for cancer prevention, to keep your insulin levels low. I like to think of it as, or just to think about the fact that when there's evidence, which usually isn't even very strong, about some chemical in our environment being linked to cancer, like we immediately ban that chemical or put up warnings. But the evidence for insulin is so much stronger as a carcinogen for hyperinsulinemia, for elevated insulin. Insulin might be 50 times higher in somebody with hyperinsulinemia than a normal person. So if you start to think of that, like literally flowing through our blood, promoting growth versus, some chemical, which maybe will provide, could cause a mutation. I mean, the insulin case is so much stronger. We have to think of that as a carcinogen, is a real threat. And once you think of it that way, the next logical step is, okay, so if hyperinsulinemia promotes the growth of cancers, and I think it's almost indisputable that it does, what diet can you follow that will keep your insulin levels down? I mean, and that leads you right to keto, because that's what it's designed to do. I'm not saying it's the only way to do it, and some people eat more carbs and fast, and some people maybe don't, just are lucky and are extremely insulin sensitive. But if you're not insulin sensitive, it just seems like such a natural step to follow, is to follow something keto like to keep those insulin levels down.
And it typically takes 10, 15, 20 years before the average person goes to their doctor and they're diagnosed with prediabetes or diabetes, meaning your blood sugars might look okay for that time, 5, 10 years, but you could be having these elevated insulin responses. That's why I recommend everybody get a fasting insulin done. You want to see that in the single digits. That's an important marker to look at what's going on. If you see that over 10, you know that something's going on. There's too much glucose and insulin being produced, and you have to make some changes. What about the role of fasting? I know fasting is another great way to drop your insulin levels. For example, Dr. Thomas Seyfried, I know he's a big fan of autophagy and achieving what he calls max autophagy, to really, he's actually seen tumors shrink before his eyes. So what are your thoughts on fasting autophagy for cancer prevention?
Yeah, I don't know as much about that as some of the other areas, but I do, you know, from things that I've read. I haven't done a lot of direct research on it, but it seems like intermittent fasting is one very successful strategy for keeping insulin down, and seems to, if you can do it consistently, seems to work quite effectively. I mean, I've seen people who have been relatively healthy on a low carb diet, and even got healthier and lost additional weight by adding in intermittent fasting. So I'm a believer in it. And if it's leading to that additional weight loss, it's most likely because it's getting the insulin levels lower. So I with fasting, of course, everyone has to be cautious and make sure they're doing it in a responsible way. But I'm a believer in it, and I'm starting to, I've been low carb for a while, but I'm trying to now add in a little bit of fasting as well. And just to add, to the point that you made before about, being unaware that you have insulin resistance for many years because your blood glucose is under control. I think that's an important point. And also to point out that even if you're thin, you may have these problems or appear thin. I actually, in my late 20s and early 30s, was still relatively thin, but had elevated triglycerides. I didn't know what that meant at the time. Now I know that that's a clear sign of insulin resistance. And I had a pretty bad diet, and there's a lot of diabetes in my family, and we're all relatively thin. and it's surprising to me. But in some ways, it being naturally thin can actually be a disadvantage because you
Yeah.
can't store subcutaneous fat. Is you sort of go like straight to the diabetes. So don't if you're built like I am, don't assume you're okay.
Yeah, no, it's a very important point. A lot of people are under the assumption that just because they're skinny, that they have a healthy metabolism and they don't have insulin resistance or diabetes. But if you're not checking your triglycerides, you want to see that below 100, even better below 70, or you're fasting insulin, you really have no idea. Some people just genetically pack on that fat around their adipose tissue, visceral fat, as opposed to subcutaneous fat. So that's what you are, exactly what your
Yeah.
genetics do. um, I'm also like an ectomorph as well, which would happen with me. So I do my testing. I make sure my levels are optimal. I want to speak about there was something I was going to talk about. We were talking about cancer, autophagy. Oh yeah, this is the question I was going to ask you. I wanted to ask you if you've done any research on industrial seed oils or vegetable oils and that link to inflammation and cancer. Have you looked at any of that?
Yeah, I mean, I looked at that a little bit, and I think there's more to the story, and certainly the inflammation is not a good thing in the context of cancer. But I decided partially, I think, through the influence of Taubes, to go with sort of the Occam's razor approach of looking at kind of like the most basic, simple explanation being the one you start with and focus on. So for that reason, I kept it more focused on sugar, and partially also because as Talbot, I think, once put it, wherever you look, sugar is on the scene of the crime. You go back to the 19th century and all these different populations, and it's a little less clear cut with some of the vegetable oil stuff, but certainly, the inflammation stuff looks real, and I in my own diet, I'm starting to try to avoid that a little more as well.
Yeah, and to be fair, a lot of these processed foods that are higher in sugar usually come paired with vegetable oil. So if you're going to have vegetable oils, typically you have high sugar, high carbs with it. So
Yeah, it's hard
uh,
to separate the variables.
correct. Yeah. So what are some other maybe things that people are unaware of that might be contributing to cancer growth? Like what are some other ways we can optimize our insulin and glucose levels so we could be proactive instead of being reactive?
Um, yeah, I mean, I think that for some people, exercise is always a question. I'm someone, based on what I've seen and read, is not a big believer that you can, fix your metabolism with exercise alone. There's the expression that you can't outrun a bad diet, which I think is true, but I do think it can help create a virtuous cycle in terms of feeling a little bit better about yourself after your exercise, and then being more inspired to follow a diet, which is low carb or keto, or following, some sort of intermittent fasting program. I've actually seen that with my teenage son, who doesn't usually focus on a good diet, but after he started working out recently, and after workout, he's actually inspired to eat in a different way because he wants to sort of keep the good feeling going. So I do think that can help. And, beyond that, I think that, just kind of rethinking our fundamental conception of what cancer is, and thinking of it as a metabolic disease that is, related to our diets, I think is absolutely fundamental. I think, a lot of people sort of get it, but can't make that cognitive leap to, well, if all this is true, therefore, hyperinsulinemia could be thought of as carcinogenic. And I think about a lot is, in the context of smoking, like, for years and years, people sort of knew that smoking was related to cancer. And then the definitive proof, started to appear in the 1950s.
Yeah.
It just took a really long time, even after the evidence was there, for it to sink in. And one of the people who discovered this, Richard Dahl, he's made the sort of key discoveries in cancer, lung cancer epidemiology, showing smoking was linked to cancer. Even he said, like, it was so hard for him to accept because it was such a normal part of our lives. And I think that's really where the roadblock is with sugar. It's just so hard to accept that this thing that we have all eaten our whole lives, and is part of it at the end of every meal, if not in the meal itself, to think that could be causing so much harm is just difficult for people to absorb. It took me a long time and 5 years of research, and eventually sunk in. But I think we need, you know, to get people to understand that more. And it's related to a lot of disease, but I don't think any disease scares people more than cancer, for good reason. So I think that linking sugar to cancer was, first and foremost a way to prevent cancer, but also to help with all the other metabolic problems, because if people could just absorb that, I think it'll, really make a difference in how they think about sugar.
Yeah, it's a great point about the cigarettes and cancer. It was so socially acceptable because you saw these late night talk show hosts smoking with their guest on TV. They were smoking inside of restaurants and bars, on airplanes, and doctors were promoting it, right? It was so socially acceptable. And then the research came out, but it took such a long time to change that paradigm. And then now with sugar, it's so socially acceptable. It's almost like an insult if you go to somebody's house and you say no to their apple pie or no to their whatever sugar bomb it is. And there's essentially a sugar dealer at every corner you look at, the gas station, the Walgreens, the supermarket. It's so accessible and socially acceptable that even though the research is coming out there, your research is out there, and many, many others, it's hard to make that paradigm shift. So the question is, how do we do it, Sam? Like, I know we're doing it and we're educating it, but for like the normal person who's listening and they want to share this with their family, like, what are the steps to do so?
Yeah, no, I mean, that's really, I wish I had the answer. I struggle even in my own family to convince my kids. And, there are different people who have different ideas, one being, sugar taxes, another, being more, having campaigns analogous to the ones we've had against smoking, warning labels on products. I would certainly be happy to see, cancer warning on every food that has sugar, but I think we're a long way from there. But I think it'll take, learning from what worked in smoking and trying to reproduce that. But before we can get to that level, we have to get, people to realize that this connection is real. So, hopefully that will be the next step. But, as this message gets out, people will see that we have to follow the smoking campaign, which people still smoke, but in the US, it actually has been a success. Lung cancer is one of the few success stories in the war on cancer, and entirely through prevention. And speaking of which, I just think it's interesting. I might actually write an article about this soon, that December 2021 actually marks 50 years of the war on cancer, which, as you mentioned at the beginning of this talk, has not been a success by any means. We now have, 1 in 3 women and 1 in 2 men with cancer. And that doesn't mean there haven't been some breakthroughs and some key treatments. And it doesn't mean that, these scientists aren't doing good work, but it's clearly, not been a success. And what's really interesting is that, it launched with Richard Nixon in 1971. And it was right around that time when we started to get this influx of high fructose corn syrup into our food, and, all the added sugar. So in a way, I was just thinking the other day, I didn't even write this in Ravenous, but it was sabotage right from the start. We never really had a chance to win it if all this stuff about insulin is correct, as I think it is.
So it's like they declared war on a country and then brought all the enemies into our land. It's pretty much what happened in 1971. Yeah, write an article about that. I didn't realize
I actually have to steal that line from you.
Yes, use it. Go for it, my friend. I didn't realize it's been 50 years. And it's a shame, because I believe these doctors do want to do the right thing and help people, but it's just the premise is wrong. When the premise is wrong, it doesn't really matter what the treatment is. You got to get the premise right. And if you can understand the premise is a metabolic disease primarily, then the treatment will be that much more efficient. And there's great doctors out there that I've interviewed, Dr. Jason Fung, Dr. Aaron Keneally, and a few others, Dr. Nasha Winters, yourself, who are doing great research. I am curious about this, because when I interviewed Dr. Aaron Keneally, who's an oncologist in California, she was sharing with me, and I think your research lined up, but I want to kind of get the specifics if you remember it. She was sharing with me that a regular cell has around 4 receptor sites for glucose. And she shared that a cancer cell has on average about 64 receptor sites for glucose. Have you looked into the specifics of those receptor sites with cancer versus non-cancerous cells?
I looked at it more in the context of insulin receptors, and
Okay.
it is true that cancer cells have many, typically have many more receptors for insulin, and that's one piece of evidence for this insulin hypothesis. Um, and there's actually a number of others which I find fascinating. One is that if you starting in the early 2000s, they started to sequence tumors, and be able to figure out exactly how many mutations they have. And the most common mutation of all, most common mutations of all, lie in this pathway known as the PI3K AKT pathway. But this is the pathway which is actually activated by insulin and which causes cells to then, take up glucose. And if this pathway is hyperactivated, it'll take up more and more glucose and turn on the Warburg effect, start to ferment it. So, it's a really interesting clue, I think, that that's where the most common mutations are. And so, it's led to this new picture, which is really about the interplay, possible interplay of mutations in hyperinsulinemia that, if you get a mutation in this pathway, maybe it won't take off and become a malignant cancer. But if you have it, that's going to make the cell more sensitive to cancer. It might also have more insulin receptors. And in that context, if you have hyperinsulinemia, then you're giving that cell a big growth advantage. It's going to take up more glucose than other cells. And once a cell is taking up excess glucose, it really, I'm borrowing this language from Craig Thompson, who's one of the most influential cancer scientists alive, the president and CEO of Memorial Sloan Kettering. And he said that, when a cancer can eat like that, it's no longer thinking about dying. It's thinking about, now I can do a lot more things. It can take all that glucose, can ferment it, and it can use parts of the glucose to actually, create daughter cells as sort of re-engineer the building blocks for daughter cells. And what's fascinating to me is that you think about this in the context of evolution. Cancer cells start to behave like single-celled organisms, right? They sort of break down this collective agreement that we have among all the cells in our body to work together. Instead, they're just out for themselves. And if you think about a cell in the wild, microorganisms growing, that's all they do. They take up glucose when there's glucose, and they make as many copies of themselves as they can. That's their evolutionary strategy. There's no glucose, there's no nutrients around. They sit and wait and try to conserve themselves, autophagy, as we talked about, until food comes around. So, you can see that our own cells, have retained, through billions of years of evolution, retained these basic mechanisms. And, some scientists talk about it as almost like a reversion to an earlier form of metabolism. That gets into some kinds of technical debates. But the point is that, this is something we know about in biology. And Craig Thompson makes this point by showing a piece of bread in his talks, and he shows mold growing in one spot of the bread. And he shows that, after a while it gets near the crust and they no longer have enough nutrients to grow. They need the glucose and nitrogen. And then, they metastasize just like a cancer cell. It spreads out to another piece of the bread, and then you see them eating and growing. So, it's really fascinating to me that, this core biology really goes back to microorganisms.
Yeah, that's fascinating. You mentioned the molecule called PI3K. Is that what you said?
Yeah.
That's a molecule. It's not necessarily a genetic pathway. Is that right?
Yeah, it's an enzyme, actually.
It's an enzyme. Okay. Is there a way to test for that?
You mean to test if it's mutated?
To test if it's mutated, correct? Yeah.
I should know the answer to that. I mean, if you have cancer, then you can, get the test that will show you which mutations you have. If you don't have cancer, can you just go in and try to find out if you have a mutation in that pathway? I'm not sure you can, but it's an interesting question.
So if you did have cancer and you went in and tested this, would it give you an idea of specifics to the type of treatment you would want to do, depending on the way that the cancer is metastasizing? Is that what it could do to help you kind of figure out the solution?
Yeah, if this, I didn't really write much about this in my book, and so I wouldn't, if anybody's listening out there, I wouldn't take my word on this without doing additional research. But it's certainly true that based on which particular mutation you have, the the doctor, the oncologist will devise a different treatment. And, unfortunately, a lot of, this is a lot of what Thomas Seyfried talks about, that in general, these kind of targeted therapies to specific mutations haven't been as successful as we would have liked. And cancer cells, unfortunately, turn out to be even more complicated than anybody imagined. There are mutations all over the place, and many of them seem to be irrelevant to cancer. But if there are some cases where they can, successfully target your therapy according to mutations. And if you have a cancer that appears to be, have a PI3K mutation or something in that pathway, then, they can devise a metabolic strategy accordingly, and, may choose specific drugs, to help slow down the consumption of glucose, or the way that cancer is using that fuel. And, what's really exciting, I don't talk about this in my book because the science is really early, but what's exciting is that there are, a series of PI3K blockers in the works. And initially they didn't work very well, and they're still in trials. But the scientist who's been leading the way on this is Lewis Cantley. He's at Weill Cornell. He actually discovered PI3K and its relationship to cancer. He's now doing trials where he's combining PI3K with a ketogenic diet, because the problem was, if you block PI3K, that's how a cell actually responds to insulin. So if you block it, your insulin levels rise. So you want to prevent cancer, but you're raising insulin levels, which is what you don't want to do. So he's now combining it. This is mostly in rodent studies thus far, combining the PI3K inhibitors with the ketogenic diet. And, the early results have looked quite promising, but, it's too soon to say.
What's his name again?
Lewis Cantley, Cantley.
Awesome. I'm going to look him up. That's interesting.
Yeah.
What's also interesting, Sam, is that, what does it take? About 10 to 15 years? Like, if cancer starts growing in the body today, how long does it take for it to be diagnosed on average from a doctor? Is it about 10 to 15 years, would you say?
Yeah, I think that's about right. I mean, it can vary from cancer to cancer, but it's usually, many, many years.
Yeah. And we said earlier that if insulin begins to rise, it's typically 10 to 15 years before that's diagnosed. So it's interesting how both of them kind of go together before a diagnosis is made. Just something that came in my mind.
Yeah. No, I've thought about that as well. A lot of people know about the correlation between diabetes and cancer, but, that's because diabetes, takes place over, many decades, and so does cancer. But if we could see that correlation earlier, it would make a huge difference.
It's estimated that about 1 billion people on planet Earth have diabetes, and another 4 billion have pre-diabetes, meaning in about 10 years, those 4 billion could turn diabetic if we don't make a shift here, which is a scary thought. My final question to you is this. You are well-versed in cancer research. You have a book all about it. What are 3 action steps that we can do today that could yield us some of the best preventative measures to preventing cancer in the future?
Yeah, well, I mean, first and foremost, eliminate sugar. That's my number one takeaway. Beyond that, I would say, we'll count that as number one, I guess. Number two, I would say that, if you are insulin resistant, as the vast majority of American adults are, you should look into, doing, whatever you can do to, reduce your insulin resistance, as we've talked about, the ketogenic diet, intermittent fasting. So those are 2 things. And then I'm not discounting that there are many other things, obviously, if we're talking about cancer in general, you don't want to smoke, hugely important. Some cancers are linked to, radiation, that's controversial, but, it's not, I don't want to make it sound like everything is diet related, but I do think that, that's kind of the most fundamental thing you can do. Maybe number one, not even just saying sugar, but saying liquid sugar, drinking sugar, because that seems to be even faster way to insulin resistance. And then if you are insulin resistant, of course, thinking about sugar more broadly in terms of cutting refined carbs as well. And beyond that, I would say, just trying to think rationally. I mean, one thing that I've tried to do is to look at the war on cancer and what's failed and what's succeeded. Not much has succeeded, but focusing on prevention rather than treatments, which haven't worked as well, I think makes a lot of sense. And if we're going to be panicked about things, being panicked about the right things, because I actually think that there's a lot of anxiety about chemical carcinogens, which, are not a good thing, but often aren't very strongly linked to cancer. I mean, one famous example would be diet sodas. I don't know that diet sodas are good for you. I don't recommend that people take them, but they're actually not linked to cancer. I mean, the evidence there is not strong. And so I see a lot of people drinking regular sugar sodas, which I do think are linked to cancer, and instead of diet sodas, because they think the chemical in the diet soda causes cancer. So just thinking rationally about what we actually know and don't know about cancer, I think can make a real difference.
Great share. Your book can be found on Amazon. It's called Ravenous, Ravenous, Otto Warburg, the Nazis and the Search for Cancer Diet Connection. We're going to put a link down below. Where else can the listeners go check you out, Sam?
I'm on Twitter at Sam_Apple1, and I have a website, samapple.com. And yeah, that's about it. I tried to get the Instagram going, but I think I'm giving up. I'm not good at it.
We'll put your social media and your website and the link for your book down below. Sam, thank you for your tremendous research, and it's really much appreciated by me, the audience, and the world, especially because, as you mentioned, one of the scariest things is that C word, cancer, and we all want to be proactive. Like Einstein said, who had a relationship with Warburg, intellectuals solve problems, geniuses prevent them. So let's all be geniuses here. So thank you so much for being a genius and empowering us all to be a genius.
Thank you so much.